So today we're going to begin our introduction to the finite difference method. So what we're going to be seeing through these next videos is that the finite difference method is a way of computationally solving complex partial differential equations where we don't necessarily have an answer or a solution for our problem. But today is just the introduction. So here you can see we have some curve, g of x. So it's just some function where it changes with x, and the value is given by this curve. And so what we do in the finite difference method is we take this curve and we discretize it, or we break it up into small segments. So here we're going to break it up into segments. We'll have, this is going to be x1, x2, x3, and x4. And so in general, we can generalize these and call them our values. These are going to be x sub I. So each of these points has some value of the function associated with it. So this would be g of x1. We'd have x2. This would be g of x3. And up here we have g of x4. And we'll write this last one in for completeness. And so just like we've generalized these, we can generalize our points on our curve. These are just going to be our values g of xi. So at some point xi, the function has some value. So with this, we see that we've spaced these out. There's a uniform spacing between them, and the distance between our points is delta x. And so we're going to be using a constant grid spacing, or a constant delta x, for our equations. So these are all going to have a difference of delta x between the points. And so what this allows us to do is it allows us to refer to specific points not needing a curve, but we'll refer to them as, if we have some point x sub I. So for instance, this point here, if we wanted to say, what's the point to the left? Then the point to the left, this is going to be xi minus 1, where xi minus 1, it's related to our original value. This is just our original value minus delta x. And we can do the same thing then for the right side, where we can refer to our values of x plus 1. This is just x sub I. Rather than being minus delta x, now this is going to be plus delta x. And so this is how we can generally refer to specific points in our curve and on our function.